Okay, so always the same type of substitution. Okay, so the first term is m minus 1, x to the n. Second term, minus 3, m x to the, is that the wrong? No. Plus 5, x to the n, 0. Okay, divide by x to the n. So this is m squared minus m minus 3n plus 5. So n squared minus 4n plus 5, 0. Okay, if you want, you can use the quadratic formula that these two solutions, n equals 2 plus or minus I. Okay, how do we interpret this? 2 tells us what?
Coefficient.
2 tells us the exponent, this 1 tells us the coefficient. Okay, so it's C1, so this is the exponent of x, this is the coefficient of natural log. X squared cosine, let me write in parentheses, 1 times natural log x. Plus C2 x squared sine times sine of 1 times natural log x. Pretty simple. So it's not too bad. Just one thing that you should be careful of, after this section, I tend to see a lot of people mixing up the two. Okay, so right after this, we're going to return to equations with constant coefficients. This is going to go away. Okay, so actually we'll be talking about the systems of equations next time. So, you know, I don't know, so just be careful not to confuse them. And if you want to make sure that you're not confusing them, then make the trial solution each time. Okay, so I know you might have gotten into the habit of not using the trial solution for constant coefficient equations. If you always make the trial solution, then it will be difficult to confuse them, because if you use the wrong trial solution, the method is going to fail. All right, so higher order equations are no different. If you look in the textbook, some of you might have picked up on it already. There's a formula that allows you to move from the differential equation to the auxiliary equation. You know? So, like I said, if you look at the coefficients, 1, 1, right? 5, 5. The only one that differs is this. You know how this is related to the coefficients here. It's pretty... it is minus 1. What if it were...
It's that minus the coefficient of
It's this coefficient minus this coefficient. Why? Because this gets distributed to m squared and negative m. Okay, so if you look in the textbook, you'll see a formula that the auxiliary equation for order 2 is a m squared plus b minus a m plus c equals 0. And I guess if you want, you can use that, but the problem is that there's an equation for the auxiliary equation for every order. So there's an equation for third order equations, fourth order, and so on. Okay, so I would suggest not using the formula and making the substitution each time. Okay, so this is no different with higher order equations. other than you can have multiplicity greater than 2, but like before, you just continue to multiply by that factor of log x. So, let's do a third order equation. Alright, so we need 3 derivatives. Okay, so the third derivative is m minus 1, m minus 2, x, m minus 3. So, you see what will happen, so if I multiply the third derivative of y by x cubed, then I get m minus 1, m minus 2, x to the, let's see. Plus 6 times m minus 1, x to the n. Plus 7 times m x to the n. Plus x to the n. Okay, every term has a factor of x to the n, divide by it because it's not equal to 0. Alright, so this is m minus 1, minus 2, 6 m minus 1, 7m, okay, last term is 1. Alright, so if you multiply these first, you get m squared minus 3m plus 2, right? So after multiplying by m, that makes m cubed minus 3m squared plus 2m. That's from the first term. And the second term, 6m squared minus 6m plus 7m plus 1, 0. Okay, so I have m cubed plus 3m squared minus 4 plus 3. Anyone recognize this polynomial? Yeah. Yeah, this is m plus 1 to the third power. Is this okay? If you don't recognize this, you can use your calculator to find one of the solutions, and there will be only one solution. And then you can use synthetic division to write a quadratic and all of that. This is good. Yes, no. Well, so remember I mentioned the rational roots theorem once. The only possible rational solutions are factors of this number, plus or minus 1, divided by factors of this number, plus or minus 1. And I can tell for sure by looking at this that any positive number cannot be a solution, because you'll never get 0. So the only possible rational solution is -1, and if you check, it is a solution. Okay,
Is that true no matter how many terms are involved?
If they're all added together, then it must be a negative solution if it's a real number.
Well, I mean, is it, does the solution must be the last term divided by the coefficient?
It's a factors of the last term.
Factors of the last term.
And that's if it's a rational solution.
Okay.
But if it's an irrational solution, then it could be something else.
So that is true for any
for any polynomial, you divide factors of the last term by factors of the first, the coefficient of the first term, and that gives you a list of possible solutions. Okay, so, well, let me do it once. Alright, so, if you use synthetic division, you pick off the coefficients, right? So 1, 3, 1. The only possible rational solution is -1. Okay, how does this work? First number comes down, second you multiply. Add. Multiply. Add. Multiply. Add. This is the remainder. That means that x plus 1 or m plus 1 is a factor. Okay? So that tells us that this is m plus 1. So since -1 is a 0, m plus 1 is a factor, and the other factor is n squared plus 2n plus 1. Okay, and then this factor is m plus 1 times m plus 1, so it's m plus 1. Okay, so that means that we have only one solution, m equals -1, right, with multiplicity factors. So, so the general solution, okay, this gives us x to the -1, and then for the other two, we multiply by log x. Is the second solution, x to the -1 multiplied by n to log x. Third solution, x to the -1 multiplied by natural log x squared. Okay, and I would use parentheses so that it doesn't look like it's natural log of x squared, it's natural log of 1 squared.
That's the entire school.
We only have 10 minutes left. Why don't we try this next one at home? So, I mentioned at the beginning